Picture yourself in a room full of gadgets, each with its own special role. One lets you talk to friends anywhere in the world, another turns numbers into colorful charts, and another helps you design cool projects or edit videos. These aren't your usual hammers or screwdrivers, they're ICT tools, the digital tools that keep our world running. Today, we'll get to know these tools, what they are, why they're important, and how they work. By the end of our lesson, you won't just be able to name them, you'll feel confident using them in real life. Now for the common tools and equipment in computer programming, which are grouped into two categories, hardware and software. Hardware refers to the physical parts of a computer system, and software, on the other hand, refers to the programs and applications that run on the hardware. Both are essential. Hardware provides the platform we work on, while software gives us the environment to write, test, and run our code. And the most important device is the computer itself, which we use to write code, run programs, and test software. This can be either a desktop or a laptop, depending on the programmer's preference and requirements. Without hardware, programming would not be possible because it provides the platform where all the work takes place. Let's now focus on software, which refers to the programs and applications that run on hardware. In computer programming, there are several important types of software tools. First, we have Integrated Development Environments, or IDEs, which combine editing, debugging, and compiling in one place. Examples include Visual Studio Code, IntelliJ IDEA, and PyCharm. All right, so for example, when you open PyCharm, it might look a little overwhelming at first, but don't worry, it's really just a few main parts. Right here, you've got the editor window. That's where you type your Python code. For example, print hello world. Simple enough. And click this Run button here to see if the program runs. Right here, and yes, it runs. There is hello world here, and here says process finished with exit code 0, meaning process finished, program has stopped running, and with exit code, meaning a number returned by the program to indicate how it ended. And 0 conventionally means success, because non-zero numbers like 1, -1, or etc. usually mean there was some kind of error or abnormal termination. So now we have a program. Then code editors. These are lightweight programs designed primarily for writing and editing code quickly, without the extra features that come with full integrated development environments, or IDEs. While IDEs provide a complete set of tools, such as debuggers, compilers, and project managers for handling large and complex projects, code editors focus on simplicity and speed, making them ideal for small tasks, quick fixes, or scripting. They open faster, use less memory, and provide a clean workspace for coding. Popular examples include Sublime Text, which is known for its speed and powerful search functions, Atom, which is open source and highly customizable, and Notepad++, which is lightweight and supports many programming languages. Then we have version control systems, often called VCS, are tools that help developers manage changes to source code over time. Instead of simply saving files manually, a VCS records every modification made to the code, allowing programmers to track who made changes, when they were made, and why. This is especially important when multiple people are working on the same project because it prevents conflicts and makes collaboration smoother. With a VCS, developers can roll back to earlier versions if something breaks, experiment with new features in separate branches, and merge those features back into the main project once they're ready. Common examples include Git, which is widely used in modern software development and platforms like GitHub. Subversion, or SVN, which has been popular in enterprise environments, and Mercurial, another distributed system similar to Git. For students, the key idea is that version control acts like a time machine for code, ensuring that progress is saved, teamwork is organized, and mistakes can be undone without losing valuable work. Then we have repositories and collaboration platforms. These are online spaces where programmers store their code and work together on projects. A repository is like a storage container that holds all the files, code, and history of changes for a project. It keeps track of every update, so developers can go back to earlier versions if needed. A collaboration platform builds on this idea by adding teamwork features, allowing multiple people to contribute, review each other's work, and manage tasks in one place. Popular examples include GitHub, GitLab, and Bitbucket. These platforms make coding a group effort, similar to how students share and edit a group project document online, but with stronger tools to ensure every change is recorded, organized, and easy to manage. In short, repositories are where the code lives, and collaboration platforms are what make teamwork on that code smooth and efficient. Another important type of software is compilers and interpreters. These are tools that translate the code written by programmers into instructions that the computer can actually understand and execute. A compiler takes the entire program, translates it into machine language, and produces an executable file. This means the program can run quickly because it has already been converted before execution. Examples of compilers include GCC, which is the GNU compiler collection, and Clang, which is widely used for C and C++ programming. On the other hand, an interpreter works differently. It reads the code line by line and executes it immediately, without creating a separate file. This makes interpreters useful for scripting and testing because you can see results right away. Examples include the Python interpreter and Node.js for JavaScript. The key difference is that compilers prepare the program ahead of time for fast execution, while interpreters run the program directly as you go. Together, compilers and interpreters are essential because they bridge the gap between human-readable code and machine-executable instructions. Another type of software that programmers use are debuggers. Debuggers are tools designed to test and debug code, meaning they help us find and fix errors in our programs. When writing code, mistakes are almost unavoidable. Sometimes the program doesn't run as expected, or it produces the wrong output. A debugger allows us to pause the program, inspect what's happening step by step, and identify where the problem lies. For example, GDB, which stands for GNU Debugger, is commonly used with C and C++ programs. LLDB is another debugger that works closely with Clang and Xcode. Most modern IDEs also come with built-in debuggers, making it easier for developers to test their code directly while they're writing it. The main idea is that debuggers act like detectives for our programs. They investigate what went wrong, show us the exact line or variable causing the issue, and give us the chance to fix it before the program is released. Another type of software that developers rely on are package managers. Package managers are tools that help manage software libraries and dependencies. When programmers build applications, they often use pieces of code written by others. These are called libraries. Instead of manually downloading and installing each library, a package manager automates the process, making sure the right versions are installed and that everything works together properly. For example, NPM, which stands for Node Package Manager, is widely used in JavaScript projects. Pip, the Python package installer, is used to add and manage Python libraries. Maven and Gradle are popular in Java projects, while NuGet is commonly used in .NET development. The main idea is that package managers save time and reduce errors by handling the complex task of installing, updating, and organizing all the extra code that applications depend on. In simple terms, they act like a librarian who keeps track of all the books you need for your project, making sure you always have the right edition on hand. Another type of software that developers use are build automation tools. These tools are designed to automate repetitive tasks in the software development process, such as compiling code, running tests, and deploying applications. Instead of doing these steps manually every time, build automation tools handle them automatically, saving time and reducing human error. For example, Jenkins is a popular tool that continuously integrates and tests code whenever developers make changes. Travis CI and Circle CI are also widely used for continuous integration and deployment, especially in collaborative projects. Other tools like Make and Ant help automate the process of compiling and building programs. The main idea is that build automation tools streamline the workflow, ensuring that code is tested and deployed consistently. In simple terms, they act like a machine in a factory assembly line. Once you set the process, the machine keeps building, testing, and delivering the product without needing constant manual effort. And now, when we talk about computer system servicing, it's not just about hardware and software. It also involves tools and equipment that help us maintain and repair hardware. First, we have hand tools like screwdrivers, pliers, and anti-static wristbands. One of the most basic hand tools we use in computer servicing is the screwdriver. For example, when we need to upgrade or repair a part inside the computer, the first step is to use a screwdriver to remove the screws that secure the side panel of the case. Once the servicing is done, we use the same screwdriver to fasten the screws back, making sure the case is properly closed and the components inside are protected. Without a screwdriver, we wouldn't be able to safely access or secure the computer's internal parts. These are basic but essential for opening up computers, installing parts, and keeping both the technician and the components safe from static electricity. Next, we use diagnostic software, which helps us check system performance, identify hardware issues, and troubleshoot problems. This is like having a doctor's tool to examine the health of a computer. We also rely on cable testers and multimeters. Cable testers verify that connections are working properly, while multimeters measure electrical values such as voltage and resistance, important for ensuring safe and correct operation. Finally, cleaning kits are necessary because dust and dirt can cause overheating or damage. Keeping computers clean helps them run smoothly and last longer. Altogether, these tools and equipment make up the toolkit of a computer technician, ensuring that servicing is accurate, safe, and effective. In visual arts, students also use different tools and equipment to create and share their work. For example, digital cameras and scanners let them capture or digitize artwork. Graphic design software like Adobe Photoshop or Illustrator allows them to edit images and design graphics. Tablets and drawing pads are used for digital illustration and painting, while 3D modeling software such as Blender or Autodesk Maya helps in creating 3D art and animation. These tools combine traditional creativity with modern technology, giving artists more ways to express themselves. In telecommunication, hardware and software work together to make communication possible. Hardware includes devices like modems and routers, which are used to convert signals from telephone lines or cable systems into digital data that computers can understand, and then back again when sending information. Routers, on the other hand, direct that data to the right device in a network, making sure each computer or phone gets the information it needs. For example, DSL modems and cable modems connect homes to the internet, while wireless routers allow multiple devices to share that connection without using cables. Together, modems and routers make it possible for us to access the internet and communicate across networks. Next, we have switches and hubs. These are networking devices that connect multiple computers or devices within a network. A hub works like a basic connector. It sends data to all devices in the network, even if only one device needs it. A switch, however, is smarter because it directs the data only to the specific device that needs it, which makes communication faster and more efficient. For example, in a school computer lab, a hub could connect all the computers together, but a switch would make sure each computer receives only the data meant for it. Both are important in building networks. Then we have repeaters and extenders. These are devices that help strengthen or extend the range of a network signal. When data travels over long distances, the signal can become weak or distorted. A repeater takes that weak signal, amplifies it, and sends it forward so communication remains clear. Extenders, often used in Wi-Fi networks, rebroadcast the signal to areas where it would normally be too weak. For example, in a large building, a Wi-Fi extender ensures that even rooms far from the main router can still connect to the network. These devices are important because they keep communication reliable across wider areas. Another important hardware in telecommunication is the antenna. Antennas are devices that transmit and receive radio waves, making wireless communication possible. They're used in systems like Wi-Fi, mobile phones, and radios to send and capture signals without the need for cables. Different types of antennas serve different purposes. Yagi antennas are designed for long-distance directional signals. Parabolic antennas are often used for satellite communication, and dipole antennas are common in everyday radio and television systems. In short, antennas act as the bridge between devices and the airwaves, ensuring smooth wireless communication. Then we have base stations. Base stations are equipment that connect mobile devices to a network in cellular and radio communication. They serve as the link between your phone and the wider network, making calls, texts, and internet access possible. Examples include large cell towers that provide coverage across cities, as well as smaller units like microcells and femtocells that improve signal strength in specific areas, such as buildings or neighborhoods. Without base stations, mobile communication would not be possible, since they form the backbone of wireless connectivity. In telecommunication, software is just as important as hardware, and one key example is network management software. These tools are designed to monitor, manage, and troubleshoot the performance of a network. They allow administrators to see how data is flowing, detect problems like slow connections or outages, and fix issues before they affect users. For instance, programs such as SolarWinds Network Performance Monitor, PRTG Network Monitor, and Nagios provide dashboards and alerts that help keep networks running smoothly. In short, network management software ensures that communication systems remain reliable and efficient. Then there's communication protocols. These are software rules that define how data is exchanged over a network. They make sure that devices can understand each other and follow the same standards when sending and receiving information. For example, TCP/IP is the basic protocol that allows computers to communicate across the internet. VoIP enables voice calls to be transmitted over the internet instead of traditional phone lines, and SIP manages the setup and control of voice or video sessions. Without these protocols, devices would not be able to speak the same language, and communication would break down. And finally, we have telephony software. It refers to applications that manage voice communication over networks. Instead of relying only on traditional telephone systems, these programs allow voice calls to be transmitted digitally, often through the internet. They make it possible to set up, control, and manage calls efficiently, whether for personal use or in business environments. Examples include Asterisk and FreeSwitch, which are open-source platforms for building phone systems, and Skype for Business, which integrates voice calls with messaging and video conferencing. Telephony software is important because it brings flexibility and cost savings while also making communication more accessible across different devices and locations. So we've just identified different ICT tools and equipment, understood their purposes, and discovered their basic functions. These aren't just gadgets. They open doors to communication, learning, and creativity. As you continue your ICT journey, always remember to use these tools wisely and effectively. I truly appreciate you for watching and supporting this video. Your time and attention mean so much, and I hope you gained something valuable today. Until next time, keep exploring, keep learning, and keep innovating.